let's construct a single artificial neuron. So let me just get the laser pointer. Okay, so what happens is this is the cell body. Remember, try to keep in mind the analogy of the biological neuron. So this is the cell body, and then we have the axon from a different neuron and its synapse, which connects to the dendrite, which in turn connects to the cell body. So what's happening is we're getting these inputs, X, which are being weighted by the weight parameters W. And what happens is you add them all up and then apply activation function. So it's like a weighted sum with a nonlinear activation function. So like I said, inputs are X. This is the data we have, X. And the relevance or the weight of each input is weighted by a parameter W. And the parameters W are not under our control. We initially set them to be some random value, and then the neural network learns to adjust these parameters such that we get the desired output. And here's the weighted sum taking place in the cell body. And the nonlinear activation function is there such that we can learn complicated functions. If it was a linear activation function, then we could just learn linear relationships between variables, and then the values outputted. So mathematically, all that's happening is the neuron takes in some input data, adds a bias, and then weights the inputs and the bias, adds it all up, and then transforms it using a nonlinear activation function. And this is the notation you'll commonly see in literature. And this Z1 this stands for the first neuron in the layer. Then Z2 is the second neuron. Here on the right is just a single neuron here. Usually this step here is depicted as a single neuron right here. But this diagram splits it up into two steps. But overall, this is just one neuron. If you had 3 neurons like this, then you would have 3 of these here, and then all these weights or these weights will be associated with this neuron, and then you'd have some more weights for the second neuron, and so on. But what happens is here's the weighted sum, and then here's the activation function applied to the weighted sum. But don't worry too much about this. This is just the mathematical notation. Okay, so you're going to do a quick exercise to see how we can manually construct this process of passing in the data, summing it up, and then applying a nonlinear activation function. We're just going to be using just random data for this. Okay, so before moving on, please try to complete this quiz. What does a single neuron do? So please pause the video and have a think. So a single neuron just performs a weighted sum of the input vector, adds a bias, and then applies a nonlinear activation function. And the second question, what is the difference between an artificial and a biological neuron? Try to think of at least one distinct difference between the two. So there are many differences, but one, for example, is that biological neurons serve very different purposes, and there's many different types of biological neurons, each that serve different purposes, while artificial neurons are pretty much all the same. All right, thank you.